Okay, drum roll. Ooh, 84%. Oh, well. Correct answer is C, 7.5 megahertz. Oh, for a little light reading. You know, when you enter college after a successful high school career, you've probably learned 18 to 20,000 words in the English language. By the time you leave college, do you know how many words you have in your vocabulary? Something like 2,000, he says. Depending on the student, between like 35 to 40,000 words, somewhere up in that range. Okay, that's a lot of words per day. So here are your words for today. Monochromatic. What do we mean when we say we have monochromatic light? That word could come up on the final exam. Who knows? Light, which is monochromatic, has one and only one color, one wavelength, one frequency. So, for example, this laser is green. It has just that frequency in it. That's it. No other frequencies. Just 532 nanometers, whatever frequency that corresponds to. Not only that, a laser beam is what we call coherent. That means every part of the light beam has the same wavelength and phase. It's just like it is a plane wave. And indeed, the way you create a laser is to set up a standing wave in the laser cavity. And there are various kinds of lasers. But for example, this one has a little crystal in it. And that forms the laser cavity. And it has mirrors at both ends. And you make one of the mirrors a little bit leaky so that light from the standing wave comes out of it. So somehow the energy source creates this standing wave, and then it leaks out in the laser beam itself. But that beam is monochromatic and coherent, which kind of flies in the face of what I was just saying, that light in the visible or ultraviolet, et cetera, consists of photons, wave packets, or little individual particles. Well, that's true if they all line up and march in the same rows together, then you can create that, but we'll get to that in a minute. Now, we talk about the polarization of light, and that corresponds to the direction of the change of the electric field. So if it's in the y direction, we would say the light is polarized in the y direction. Of course, you have, at the same time, the magnetic field 90 degrees away from it, but we generally refer to the polarization of light by the direction of its electric field. Now, oddly, we can have circular polarization for light. And that's the case where the electric and magnetic field direction spins around the axis of propagation. And that looks like this. If you're standing at one point at the origin of this coordinate system here, you see that vector sweeping around in a circle. That would represent what the electric field vector is doing at any moment at that point. It's sweeping around. And of course, there's a magnetic field vector 90 degrees behind it at that point, too. So that's called circular polarization. Circular polarization is really useful. And it also happens to be how most light emitted from atoms is given off, either left-handed or right-handed circularly polarized, not vertically polarized. You'll play with polarizing filters in DL and cross them against each other and make the intensities go away and so forth. But there's a very practical thing that you can do with circular polarization involving photography. Now, with photography, oftentimes if you have a nice camera, it'll do through the lens metering of the light coming in. But to get it to go onto the meter, it has to bounce off a surface. It turns out when polarized light hits a surface, like the hood of your car, for example, it bounces off. Only the transverse polarization bounces off a mirror and goes into your eyes. That's why when you have sunglasses, if they're polarized in the vertical direction to eliminate glare off of glossy surfaces and so forth. Also makes it hard to view certain liquid crystal displays because the light coming out of your computer screen is also polarized. You can try it with your sunglasses. If you have polarized sunglasses, if you turn them at different angles, you'll see different effects. Anyway, so with photography, if you put a filter on the front of your camera which takes in all sorts of polarizations of light and only lets through circular polarized light. You can do a lot of photography tricks with that, like if there's a hazy day, you can make the haze practically disappear because the haze is polarized light from the sun or other light sources coming at you. Or you can, if you're taking a picture of water and there's some other light source, if you turn the polarizing filter, you can see into the water where you can't even with your own eyes unless you have polarizing filters in front of your eyes. A lot of fun stuff, but you have to use a circular polarizing filter to do proper through the lens metering with cameras if you're into that stuff.